minus 1 minute, everyone.
Don't be shocked if we hold.
Back ground for a safe touchdown, hopefully.
They are not seeming to care about it. Here we go. Booster what? They're not seeming to care about it on the tech feed, but we can confirm and touchdown.
Hello everyone, you are watching live coverage from Launch Complex 1A in New Zealand, as we're just less than 25 minutes away from the launch. Today will be the launch of another Electron rocket, this time with the mission, Get the Hawk Out of Here. That is really what the mission is called. Today we aren't joined by anyone but me. I'm here today. I'm the owner of this channel, host, organizer of this channel. So yeah, basically that's it. I'm myself. Oh no, he's not here today. He won't be here today. Okay, so we're just less than 25 minutes away. You're looking at a live views of the boys count that's actually here, somehow here again. So yeah, for this live coverage we'll talk about all the details of this mission, more with videos that are going to be displayed by Rocket Lab itself. So because Rocket Lab stream will be starting in about a minute. It says here now waiting for Rocket Lab, so we should see that broadcast start in a few minutes. In about 3 minutes or so they should start. Let me just check if there were any new tweets. No, still from 27 minutes ago. That liquid oxygen propellant loading to Electron first and second stage, progressing smoothly. So yeah, everything's still looking good for that on-time liftoff. There was a little bit of a delay in the window, maybe just to check stuff out. But I saw that the weather was favorable for today's launch so far, so I hope we're gonna see that liftoff very shortly. 22 minutes. So yeah, today's mission, Get the Hawk Out of Here. Basically, the payload itself is called HawkEye 360, and the full name HawkEye 360 Cluster 12 and Kestrel 0A. HawkEye. Oh. Nightbot is here today. I've added him back. Sometimes scare me. Stop spamming words for. Oh my god, bro. Why is he here again? Anyway, HawkEye 360 Cluster 12 here. HawkEye 360 is a radio frequency geospatial anal. Oh my god, bro. I cannot pronounce anything. It's a provider. Their constellation, comprised of 15 satellites and 5 shells, aims to deliver precise mapping of radio frequency emissions anywhere in the world. That's pretty cool. And we have the Kestrel 0A demonstration mission of HawkEye 360's new spacecraft design, known as Block 3 Lite. So that's pretty cool. So yeah, their coverage should be starting in a minute or so. Just waiting on updates, anything. Let me just refresh, do stuff. Let's see what they've done now. Yeah, they can do anything at this point. Alright, just about 21 minutes to launch now. I'm just waiting on New Zealand or gosh, Rocket Lab to start their coverage. The launch is from New Zealand, if you didn't know yet. Exact location, let me see if I can pronounce this right. Mahai Peninsula. Okay, that last was probably the first. Was probably mid. Let's see. Let's check this out. Rocket Lab has not started the rockets yet. Is there another old Rocket Lab? What is going on? Sometimes the team is just doing stuff, man. Like, no preps. Now that we're just taking a look at the missions here. Oh,
Yes.
coverage has popped up for a Rocket Lab here now. We will be taking a look at that later. You can, I don't know if you can hear it. I hope not, because yeah. I'll actually put it on my phone as well, so I don't have to do it on OBS. Alright, we should see that coverage starting shortly. I don't know what they've said. Let's see, next mission. Here, next mission. Full information of the launch here. Today's launch. Get the Hawk out of here. Rocket Electron today from Launch Complex 1A to be exact at... They have not updated the launch time here. It's actually 5:28 UTC. 3 satellites and 1 experimental satellite. So pretty interesting from Rocket stuff from Rocket Lab. So stream has started. Just saying, we're live with the broadcast for Electron's 67th mission, which is quite something. So just waiting here on their coverage to start. I think they're gonna... Yeah, this is not really up to date. Oh! And the intro has started. There we go, we got them aligned. Alright, their coverage is now starting. We're gonna switch to live views from their coverage in just a minute. If we can get that for you. So, glad to stream this once again, although I wonder where the launch broadcast... Oh, there it is. So you want to get your look at live view from the boys camp, but not anymore. There you go.
We are on the pad with...
Okay, there we go. We're aligned.
Satellites to low Earth.
Okay, we're aligned. Good. So, once again, today will be the launch of the Electron rocket here. We're just, updating the launch time now. With 17 minutes and 15 seconds to go. It's gonna take a little bit. And there are the commentators for Rocket Lab here. We're just gonna switch to our view again. But yeah, today will be the Rocket Lab launch. Today's rocket has 3 stages. The first stage, the booster. Second stage, the second stage will propel it to orbit, and the third stage, the kick stage, can propel to higher orbits, which is necessary for this mission. So once again, today's launch here, Electron with HawkEye 360s, what the payload's called, and 1 development version of that. So, just looking at beautiful footage from the rocket here while I'm just trying to update the countdown for y'all here. And we should see that there. We got the countdown back with just 16 minutes to go once again, live from New Zealand. So, we might just switch it to their commentating for a little bit. Mostly because they also have better knowledge and better video to show you what is what. So let's just get to their coverage.
Battle space. Threats lurk unnoticed. HawkEye 360 turns radio frequency signals into mission-ready answers through the first signals intelligence constellation. Revealing patterns of hidden movements worldwide, we provide America and her allies with the data, analytics, and domain awareness to act with greater speed and confidence. This is signals intelligence for the modern fight. This is HawkEye 360.
Nice one. We are super excited to have HawkEye 360's satellites back on Electron over here in New Zealand this time around. We've got another 14 minutes and 45 seconds until liftoff, so while we wait, let's throw it back to 2023 when we launched our first mission for HawkEye 360, which was also our first ever launch from Launch Complex 2 in Wallops Island, Virginia, like Marielle mentioned before. Now, that mission was called Virginia is for Launch Lovers, a nod to the US state that both LC2 and HawkEye 360 call home. So let's take a little bit of a look back.
Liftoff of Electron from Launch Complex 2, leaving US soil for the first time and on its way to space up and over the Atlantic Ocean.
I can't believe it's been 2 years already since we opened LC2, and 30-something missions later, here we are again with HawkEye on the launch pad with Electron.
And speaking of, we are about 13 minutes away to liftoff now, which means we are coming up to our go, no-go poll for today's launch. Now, our operators in mission and range control will be polled by the launch director directly for whether they are go to proceed with the countdown to liftoff or if there are any watch items for the rest of the count.
Now, stations are polled across range and launch safety, weather expectations at liftoff, if there's any probability of launch constraints, and of course, multiple engineers monitoring Electron's systems across avionics, propulsion, software, and more. Let's go ahead and tune in to Mission Control now to hear the status of today's launch, led by Launch Director Taylor Moore.
Okay, just coming back here, we're about to hear Mission Control probably do a go, no-go poll here. So, I know I switched to their commentary. They have way more knowledge than me. Although I still understand, of course, what they're saying. But yeah. Pretty important mission.
We are proceeding with the go, no-go sequence, beginning with stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCon.
VCon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
And LD sub.
LD sub is go.
Copy. The go, no-go sequence is complete. We are T minus 11 minutes, 18 seconds, and counting. We are go for the terminal auto sequence at T minus 10 minutes. From this time, the 3-word procedure is in effect.
There you have it. We are a go for today's Electron launch, and the countdown continues. We are on track for an on-time liftoff at 5:28 a.m. local time, still well before sunrise here in New Zealand. And we've got 2 T0 opportunities today, so if there's a delay for any reason in the remaining minutes to launch, then we've got a second chance to try again later in the launch window. So far, though, no watch items for the rocket, payload, or range clearance, so we are tracking nicely to schedule for an on-time liftoff. So while we are busy launching back-to-back missions with Electron, our team at headquarters in California and across multiple states are also hard at work building spacecraft and space systems products for a range of missions, a whole other part of Rocket Lab's business that isn't just building and launching rockets. And so that includes spacecraft, satellites, star trackers, radios, solar power systems, flight software, and many more of the critical components needed for missions to space.
That's right. Now, our spacecraft have supported some really exciting missions so far, like NASA's capstone mission to the moon and another upcoming mission for NASA called Escapade, this time bound for Mars with 2 of our spacecraft. Here's more about what building spacecraft at scale means to Rocket Lab and what our team is working on right now.
My name is Frank Klein. I'm the Chief Operating Officer at Rocket Lab. It's almost hard to believe how much work goes into building a satellite. A satellite that you see back there has 66 different harnesses, multiple systems, star tracker, solar panels, propulsion system, all these different elements that all have to come together.
My name is Anita Becerra, and I'm the Senior Supervisor of Space Systems Production. I have a highly skilled team that allows us to produce spacecraft at scale. What's great about Rocket Lab is that everything is made in-house. So we have things like our reaction wheels, radios, some harnessing, all of those things are made by Rocket Lab, and it allows them to reach our work cells quicker.
I mean, vertical integration is certainly something that differentiates us from a lot of our competitors. I often refer to us being a company that is getting the raw material rolled into the one side of the door, and on the other side of the door, beautiful rockets and beautiful spacecrafts leave our building.
My name is Kimberly Frazier. I'm a Senior Integration and Test Lead at Rocket Lab. So we've taken a panel approach to building spacecraft, which essentially means that we're broken down the spacecraft into smaller parts and we're building and testing it in pieces. It also allows us to swap panels between spacecraft. So if we have one panel that fails or has an issue, we can just pull in another right away. Allows us to move a lot faster.
What really helps us if you build a lot of the components in-house, that you can really look at your system from a holistic perspective. If we just look at the satellites behind us, we intentionally designed the satellite to an ideal stage, knowing what components are going to be added to the satellite. So we optimize not only the satellite, we optimize the components, so we optimize the entire system. And that also allows us to be much faster on the market because we control everything in-house.
This is where our spacecraft build begins. So we have piece parts that we receive. They go through an incoming inspection and they get assembled to a completed structure frame assembly. We have reaction wheels, PPUs, comms plates, and these are all the different sides of the spacecraft that get assembled in this area. And then they get physically integrated into the actual structural frame assembly. We put the first couple of panels on, and that's where we integrate a lot of the bulkier avionics components, and then we hand it off to engineering where they perform a lot of their tests.
Yeah, so the INT team's job is the last piece in the flow. We're really the last group that gets to touch the satellite and make sure that everything is working before it goes out the door. So we're doing a lot of the little checks along the way and helping build those up with production, and then at the end doing the big system level test showing that the whole system works together. I think the biggest challenge is just moving fast. You're more likely to make mistakes or forget things or miscommunication between teams. And so we've really tried to build in those daily tag ups, very clear work instructions, and very clear processes for this program to make sure that we all know what's going on. And if you're unsure, you know who to ask.
The pure talent that is here within Rocket Lab is absolutely mind-blowing. We're not just building spacecrafts, we're really redefining the space industry. So by having a very high vertical integrated approach, having the best people in the industry and outside the industry getting together, and also being absolutely dedicated every single day, that really makes the difference. And that allows us to grow faster than others. That allows us to be more competitive. Certainly 100% mission success. That's what we all tell our people internally. What that means is that everybody who is doing something within our company, from a design, from a building perspective, we always have the highest standard of quality that we apply to whatever we do. So we test the individual components, we test subsystems, and we test the entire system to just make sure that we always have 100% mission success.
Very cool. And as you saw, lots of spacecraft and hardware with Rocket Lab logos on them. Even the satellites on today's mission will be deployed from a motorized light band separation system built by Rocket Lab, which is a mechanism designed to safely and reliably detach the satellite from the rocket in space. Now, we are at T-minus 4 minutes, 43 seconds and counting on the clock, which means we are heading into the final moments before liftoff to get the Hawk out of here. Here's how those final few minutes are expected to play out. So first up, at T-minus 2 minutes, you'll hear the call that Electron is on internal power. And this means Electron is now running on its own power supply. More importantly, though, it also signals that Electron's flight computer has taken over the reins for the final pre-launch sequence.
Now, after that, we'll hear a call for AFTS, which stands for Automated Flight Termination System. And this confirms that Electron's onboard safety systems are fully active and its telemetry systems are verified to be transmitting data back to mission control. After that, expect to hear confirmation that Electron's liquid oxygen propellant, or LOX, has been loaded and that it's circulating within the vehicle. And then after that, a call should come that Electron's tanks are pressed for flight, and this means that the propellant tanks are fully pressurized, locked and loaded and ready to unleash the power of Electron's Rutherford engines.
What follows should be a call that high-flow engine purge is enabled, which will mean that the Rutherford engines are primed and ready to ignite. And then last but not least, our launch director will remind operators of their position in the countdown, usually at around 20 seconds to launch, right before taking us down through the final 10-second countdown to liftoff. So let's bring up the audio channels from Mission Control now so you can hear that experience from Mission Control in real time, and we'll be back with you after liftoff.
All right, and welcome back everyone to the live coverage from my commentary this time.
To all operators, from now on, there should be no red flags in your critical LCCs. Beacon LD on mission card.
LD beacon.
Please lock the auto sequence and confirm.
So just hearing.
And please confirm all flight computer ASGOs are green.
All ASGOs are green.
Okay.
Copy. We are go for auto sequence start at T-minus 2 minutes, and LD is go for launch.
So we're just hearing stuff from Mission Control now. This will happen pretty much throughout today's countdown. In the next 2 minutes, I should say. Just 2 minutes to go until the launch of Electron and Get the Hawk Out here, which is a pretty interesting name for a rocket launch. 2 minutes. Of course, we also have the boys cam here. Let me just get that for you. And there it is.
The vehicle is fully on internal power. AFTS is green and enabled for flight.
And we should get ready now to see the liftoff of the rockets. Just 1 minute, 35 seconds to go. Strong back retracted. We are ready to go for today's liftoff in 1 minute.
LOX load is complete. System is in recirculation.
LOX load is complete. Confirmation from that. Coming up to 1 minute. We're now on the terminal count. With 1 minute to go. Here, 1 minute.
Anti-geysering is disabled.
All right.
Stage 1 and 2 tanks are pressed for flight.
High flow engine purge enabled.
So, here we go. T-minus 35 seconds before the launch. We are ready for the launch here. So, let's listen in and see Electron fly once again.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Here for Electron's 67th launch. What a spectacular liftoff for Electron. And that fiery plume lets us know that we are climbing fast and soon we'll be reaching maximum aerodynamic pressure, also known as max Q, as Electron punches through the atmosphere. Our launch ops team and mission control will be calling out that critical moment shortly, so let's listen in.
Electron is supersonic, approaching max Q. Cleared max Q.
There we go. Confirmation from Mission Control that we have cleared max Q. Right now, Electron is moving at over 2,000 kilometers an hour and past an altitude of 20 kilometers. And our next launch milestone will be MECO, or main engine cutoff, in just under a minute and a half. What that involves is 3 critical actions across Electron's first and second stage. First, the 9 Rutherford engines on the first stage will shut down as scheduled. Next, the first stage will disengage and separate from the second stage. And then thirdly, the single Rutherford engine on the second stage will ignite to propel the mission on its way to orbit. So let's listen back into Mission Control to hear those 3 crucial calls.
Go in roughly 30 seconds.
"15 seconds to staging."
Enter burnout attack mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
And there you have it from Mission Control. We've confirmed a successful main engine cutoff. We love to hear that. Now, next up, we'll be seeing the fairing jettison, where Electron's fairing halves actually split apart and fall away. So keep your eyes peeled on your screen for that one coming up soon.
Confirmed.
And you just heard it there from Mission Control, a lovely fairing jettison. You can see HawkEye 360 is well and truly on its way to orbit, now traveling at 8,500 kilometers an hour, just passing 125 kilometers in altitude. What a ride for these 4 satellites.
HVB discharge holding nominal.
Guidance is looking nominal so far into the mission, which you can track in real time with the trajectory plot that will show up on the right-hand side of your screen soon. Otherwise, the total burn time for this second stage engine is around 6.5 minutes to take us all the way to a nominal transfer orbit. Now, the Stage 2 Rutherford engine is practically identical to the Stage 1 engines on the booster, apart from an expanded nozzle that helps to maximize the thrust from Rutherford and improve its overall performance. And we are now at T plus 4 minutes 32 seconds into the mission, with expected engine cutoff at around T plus 9 minutes.
Alrighty, next up in Electron's series of maneuvers is the battery hot swap, a move that's unique to Electron, given that its second stage Rutherford engine is actually powered by batteries. Now, since the engine burn lasts longer than a single battery pack can drive the pumps, the propulsion system will switch over to a fresh battery pack in order to keep the engines running smoothly. This happens super fast and can be pretty easy to miss, so keep your eyes peeled for the silver object on the right-hand side of your screen being ejected from Electron shortly.
Guidance is nominal, 200 seconds remaining.
HVB discharge holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
Battery jettison confirmed.
An excellent battery hot swap that we saw there, and we heard from Mission Control as well. So we are now at T plus 6 minutes 40 seconds into the mission, with Electron boosting along at more than 15,000 kilometers an hour.
T plus 7 minutes into this mission, you can have a look on the right-hand side of your screen. Our propellant levels are consistent at 29% remaining for kerosene and liquid oxygen. Our kerosene temperature sitting at a balmy 12 degrees compared to our liquid oxygen temperature of negative 177 degrees Celsius. And it's that cold temperature that causes the ice on the outside of Electron when it's on the pad and gives it its distinct black and white stripes. All right, we're now nearing the end of the second stage's journey with SECO, or second engine cutoff, right around the corner. So soon, that single Rutherford engine powering Electron will shut down, and the kick stage will seamlessly separate, carrying HawkEye 360's satellites where they belong on orbit. So let's chuck it back to mission control for that critical call now.
Guidance is in terminal, 25 seconds remaining.
Sorry with the jump scare there. This is stage 3 sound, which they're doing right now.
SECO confirmed.
Stage separation confirmed.
There we have it.
And there you have it. Mission Control has confirmed SECO, and the kick stage with this HawkEye payload is now in its initial coast phase around Earth. And it will be another 40 minutes or so before the Curie engine on the kick stage ignites to make its final and precise adjustments to place HawkEye satellites to a 520-kilometer circular orbit.
All right. Just going to finish here. Wow, beautiful launch there today from Rocket Lab with Get the Hawk Out of Here. So that will conclude our coverage here for today. If you want, of course, to watch the payload deployment, check Rocket Lab's YouTube channel or Twitter to watch the rest of the coverage. So that will conclude our coverage here. Thank you so much for watching. We will see you next time.